In this lesson, we're going to talk about the standard normal distribution. The standard normal distribution is a normal distribution that has a standard deviation of 1 and a mean of 0. Following what we know from the normal distribution, the standard normal distribution will have about 68% of the probability accumulated between one standard deviation of the mean, so that is between -1 and 1, 95% between -2 and 2, and 99.7% between -3 and 3. The variable that is represented by a standard normal distribution is going to be represented with the letter Z. And the values of this variable are going to be called the Z scores of the distribution. The standard normal distribution is going to be particularly helpful when we don't know the mean and the standard deviation of a regular normal distribution. We can translate the probabilities in a normal distribution into a standard normal distribution by considering the z-score defined as x minus mu over the standard deviation, where mu and sigma correspond to the normal distribution. We can also use this formula to standardize a normal distribution, meaning that instead of leading the discussion in terms of the values of the outcomes of the variable x, we would be talking about distance from the mean in number of standard deviations away from the mean. Let's consider the first example. The age of graduate students in engineering programs throughout the USA is normally distributed with a mean of 24.5 and a standard deviation of 2.5. A student is chosen at random. What is the probability that the student is younger than 26 years old? In this case, we are working with a variable x that is normally distributed with mean 24.5 and standard deviation 2.5, meaning the variance is going to be 6.25. One way that we can solve this problem is by calculating directly using our GDCs the probability. Another way that we can do this is by standardizing this probability distribution. In that case, the probability that we are interested in finding would be the probability that Z is less than the Z score, let's call it A, corresponding to the probability in the normal distribution. That Z score is going to be given by the value of x minus the mean divided by the standard deviation. In this case, the value of x that we're interested in is 26, the mean is 24.5, and the standard deviation is 2.5. When we calculate this, we are actually trying to find the probability that the standard Z score is less than 0.6, and that probability is equal to 0.7257. Now for B, we can do something similar. We are looking for the probability that x takes values bigger than 23.7. That would be equivalent to finding the probability of the standard variable bigger than 23.7 minus 24.5 over 2.5. This is the Z score, and this is equal to minus 0.32. So we are looking at the probability where Z is bigger than minus 0.32. And this probability is equal to 0.6255. Now see what percentage of students are between 22 and 28 years old. So we're trying to look for the probability that x is bigger than 22 but less than 28. If we standardize this variable, we would be looking for the probability that Z takes a value more than 22 minus 24.5 over 2.5 and less than 28 minus 24.5 over 2.5. So if we find the Z scores for this probability, we are going to find that Z has to be more than minus 1 and less than 1.4. Now, the calculation of this probability is equal to 0.7606, which means the percentage of students between 22 and 28 years old is 76.06%. Now for D, what percentage of the ages fall within 1 standard deviation of the mean, 2 standard deviations of the mean, and 3 standard deviations of the mean? We already know those answers. Between 1 standard deviation of the mean, the probability is going to be about 68%. So the probability that Z is between -1 and 1 is 0.6826. Between 2 standard deviations of the mean is going to be about 95%. So the probability that Z is between -2 and 2 is 0.9544. And between 3 standard deviations of the mean, that is between -3 and 3, the probability is about 99.7%, so 0.9973.